Okay, recording. Yeah, so what we have is x to the power of 2x squared plus 1. This question can be done easily if you already know implicit differentiation. You can take logarithm on both sides and it will be a lot easier to differentiate. However, here what we have is Amax syllables. We are restricted to Amax syllables. So this is actually still doable. What you need to understand is that e to the power of ln of x, the e and ln sort of cancel away. So it becomes an x. Can?
Yeah.
Good. So that means that you can always rewrite this as e to the ln of x power 2x squared plus 1. Okay, there's a lot of things going on, but I hope you understand. This is a power, right? So logarithm, you can always take the power down. This is not differentiation. Please don't go and bring down the power minus 1, get a new. Okay, we are just using a logarithm property. Is that okay? I highlight it blue and green. Can so far?
Which rule is this?
This is a special identity. It's not really a rule. Special logarithm identity.
I've learned this before where
in logarithms.
I've learned this before.
E and ln cancel away.
Okay.
Yes. Ln and e. How about ln and e? They also cancel away, right? Because this is ln is just a short form for log e base e. The x you can bring down, x times log e base e. That's just 1, right? So x times 1 is x. For e to the power of ln, it's the other way around. But it will still be equals to 1. In general, if it's like a to the power of log x base a, you can show that it's always equal to x. Okay, in general. In general. Okay, how to show? Can start with the left-hand side. A to the power of log x base a. Let's call this y. Okay, I don't know that y is x first. Then in that case, I can. Oh no, this one is just logarithms, no differentiation yet. Right? Let me just show you why this should be always. This y will always be equal to x. Okay, I'm trying to show that y is x. So whenever you have a as a base, wouldn't it make sense to take like logarithm? Maybe in this case, I'll take log base a. Okay. Yeah, first line I should write down. I take let the left-hand side equals to y. Then I take the log a on both sides. So what happens when you have log base a of a power something? So something can bring down, right? That's just power rule. So that guy you bring down, you multiply by log base a of just a equals to log y base a. But of course, this guy is just 1, right? It's just 1. Oh, so we are left with log x base a equals to log y base a. Well, you have base a logarithm on both sides. There's only one answer. One thing you can deduce. X equals to y. Okay, so this is equal to x. Yeah, so that's how you show it. But the main idea is you can always use the strict. Whenever you have variable as a base, variable as a power, we write as e to the ln. Okay, and then you use a logarithm to bring down the power. All right, very good. Now that you have this,
I feel I can do it.
Yeah, carry on. Yes, please.
Wait, I have a question. They ask obtain values of y and dy dx at point where x equal 1. Then isn't it just sub in x equal to 1 to like find y?
Yes, correct.
Then it's just 1.
Yeah. Yes. That's the easy part.
Oh, then
but the
okay,
dy with dx.
Okay. Okay, I know that.
Wait, the ln x wrong. It's not. The font size is wrong. You should put it as the same level as the power, right? So it's times ln x.
Okay. And then this one stays the same, right?
Correct, yes. Ln x as well. You take the entire power. So this entire thing remains.
And then you
times,
differentiate inside here.
correct, because of chain rule. So times
4x.
So here you have to be careful. What are you differentiating now? It's 2x squared plus 1 multiplied by ln x. Multiply means you get a product. Product means you need to use
product rule.
Yeah.
What the?
So we must. Yes.
Wait. Okay. Now I don't know. Okay. Wait.
Let me move the working away so we got more space. Let me bring it back. Yeah, so maybe I just show this part. The basic idea is when you differentiate. Okay, let me just write this down. E to the power of x is just e power x. But if we upgrade the x to any function of x, so we call it f of x, right? Function notation, it just becomes e to the power of the same thing, but you have to multiply by the derivative of whatever is the power. That's just chain rule, okay? Because this is the inner function, e power x is the outer function.
But in this case, fx is a product. So then you need to use product rule.
So e to the power of whatever, just copy and paste. My favorite function, easy to differentiate. Copy and paste, then times the derivative of the f of x. But of course, in this case, that function is just a product. So I just copy it down first. Can? Okay, then after that, everything copy and paste. But this part, when you differentiate, you need to use product rule. Carry on, try.
4x times ln x plus
times ln x.
Ln x plus over x plus ln become over x 10 to x squared plus 1.
Very good, exactly. Yes. Ln x becomes 1 over x. So 2x squared plus 1 times 1 over x. The x just go to the denominator. Let's just write down what you wrote. So 4x ln x. Here it's okay to not put brackets. It's clear enough. 4 times x times ln x. Then the other guy is 2x squared plus 1 divided by x. Okay, just leave it alone like this. Good enough. Then they want you to say when x equals to 1, y equals what? 1 to the power of 2 times 1 squared plus 1. That's just 1. 1 power anything is 1. And dy by dx, the lazy notation is just vertical line x equal to 1, would be, what is this? Let's see. E to the power of 2 times 1 squared, which is 2, plus 1, bracket, ln of 1 multiplied by 4 times 1 is 4 times 1. Just write it times ln 1 plus 2 times 1 squared. That's just 1 plus 1 divided by 1. What's ln of 1?
What's ln of 1? Zero.
Yes, this is 1 comma 0. Must remember. Okay, so this is 0. Then 2 plus 1 is 3. 3 times 0.
3. Wait, overall is 3.
This one is 3 times 0. Okay, so of course, it's just power 0, which is actually just 1, right? Times, let's see, what's this? Ln of 1 is 0. 4 times 1 times 0 is? 0, yes. Like a virus. The moment it comes in, everything becomes 0. Okay, so we are left with 0 plus 2 plus 1 is 3 over 1. That's just 3. 0 plus 3, 3. which is times 3, and finally we get 3. Okay? Can? Okay, okay.
Yeah.
Oh, wait. Let me know when you're ready.
Yeah.
Ready? Okay, can. Now let's teach, let me teach you something different. Logarithmic differentiation. H2 math topic. I'm just gonna go through it. Okay, now we're gonna do it a different way. So what we're gonna do is we're gonna take logarithm of both sides straight away. So previously we did a special trick e power something. Now I'm going to, ayo, I got a power 2. Sorry, let me crop this nicely. So now we're going to take logarithm on both sides. That's the first step. So it's another special trick. Whenever you have variable to the power of a variable, you usually would want to use whatever I'm about to show you. It's an easier way to do this. So what we do is we take ln of this one, ln of that one. But of course, whenever you see ln of something to the power of something, what do you do to the power?
Bring down.
Down. So you end up with 2x squared plus 1 multiplied by our ln x. Left side is ln y. Okay?
Okay.
But now,
ln x
how
over
do you
ln y.
differentiate? So that's when you need to understand that this ln y is essentially, sorry, let me hide this. Ln y is essentially a function of y. Okay? What we want at the end of the day is dy by dx. So if you think about it, what you want is dy by dx. So you're just differentiating with respect to x. So, ln y over ln x? No. What you want to do is to treat this as a function on its own. Like let's say this is capital Y. Then what you're doing is dy by dx is what you want to find.
Oh,
But this is a function in terms of y, little y. So you can use what rule? Chain rule, the splitting trick. What letter would you want to introduce?
dy, d small
okay,
y.
maybe I should use, how about, like you've seen the rate of change questions, like A, use capital A. D small y, right? Okay, good. So what is dA by dy now? What's A?
dA by dy. Ln y. Ln y.
Differentiate ln you get, if you recall.
1 over y.
1 over y, just change from x become y. But don't forget there was always an extra dy by dx tail.
Okay.
This you have just learned is a very simple application of rate of change, which you already know. But it's only a topic you will see in H2 math. It's called implicit differentiation. Okay. So what you have now is a function in terms of y. The procedure is, after you've seen this one time, you can forget it. The procedure, what you really need to do if you want to differentiate is differentiate ln, you get 1 over. Copy the variable, in this case y. Don't forget there will always be a multiply by a dy by dx tail, extra tail. This is implicit differentiation. It's outside of AMAX syllables. Okay. Equals, then since you differentiate by dx on the left, essentially, okay, what you are doing is you're sort of putting a d by dx on the left and a d by dx on the right. Like this. After you d by dx the ln y, you get this. Now you have to differentiate this product. I'm sure you know what to do. We already got the answer from before. It's just product rule. I'll save you some time. Copy and paste. It's just product rule, right? Then from there, how do you make dy by dx? How do you solve for dy by dx?
Times
y, exactly. So it's just y times of all that. But wait, what's y? Read the first line. Y equals
1. Sub y equal to 1.
Y equal to 1? No.
Wait.
Start as a last step, rate of change question. Substitute last step.
Y equals to x to the power of 2x squared plus 1.
Exactly. So then you have to replace this with x power 2x squared plus 1 multiplied by whatever is inside the square brackets, and you are done. Let's double check with the answer from before. I copy and paste and you see if it's the same. Copy. Paste. Looks a bit different. Why? Oops, sorry, left out x. Not because of the x I left out at the denominator. This one looks a bit different. Are they the same?
Are they the same?
Are these two the same?
Yeah,
yes, right. Because e power whatever something times ln x, you can always bring it up on top. So it becomes ln of x power whatever x power whatever 2x squared plus 1. Then e and ln, what happens? Cancel off, right? Remember? Special identity, cancel away, then of course you're just left with whatever we had at the front, x power 2x squared plus 1. So confirm they are the same. Okay? Yeah, this is another way to do it. And you can see that it's a lot simpler, I think. So just ln both sides, then power bring down already, differentiate both sides. But this step, it's in terms of y, you need to use a bit of chain rule. We call this implicit differentiation. You can go and Google implicit differentiation. Okay. Yeah. Okay, then dy by dx is found another way. The rest I'm sure you know how to do it. Sub x equal to 1. Okay. Can move on. Yeah, okay, good. Next question 4. Hello.
Yes.
Yes. Okay, let's begin question 4. So the gradient of a curve is dy by dx. It's equals to p plus q over x squared. Oh, you want to draw the graph? Can.
Wait, I don't want.
Can.
No, but
okay,
I
I
don't
didn't
want.
think of.
Okay,
no. You see, if there's
I
an
thought
x,
you had to.
No, actually, this one x cube. I'm also not too sure how it looks. But I know that there's a particular asymptote at x equal to 0. Then it depends because p and q are can be positive, can be negative. They never tell us. They just tell us it's a constant, so it could look something like this. That could be a okay, no. There must be a horizontal asymptote y equal to p, and p could be positive, then it will be above x-axis. Negative, then it will be below. Then your graph will curve this way, this way, this way, this way, this way, this way, or this way, this way. All 4 possibilities. You don't know. And your p, you also don't know if it should be above the x-axis, below x-axis, or if it's 0. If p equals 0, then it's the x-axis itself. So too many variables. You can't draw the graph. What you need is oh right, I haven't teach you integration. Okay, now's a good time, I guess. P and Q are constants in this equation. Okay, the gradient of the normal at a1, 4. So however the curve looks like, let's pretend it looks like this. There's a point here 1, 4. Then there's a tangent line. This tangent line is y equals mx plus c. This m here they're telling you is equals to -1. And the tangent to the curve at b2, 0. Okay, that's another point. Yeah, not enough space. Let me just stretch. Let me move my graph around. So let's say there's another point here, 2, 10. That's point B. That's point A. You draw another tangent. Again, it's y equals mx plus c. Different m, different c. So it's called m1, c1. Then the gradient in this case, oh no, they just tell you straight away it's y equals 8x minus 6. Okay. Okay. Then they want you from this information to calculate the value of p and of q. Oh, you actually don't need to do integration. You know, actually, if to go from y to dy by dx, what do? You differentiate, right? So do you think you can work backwards?
Undifferentiate.
Just do reverse. Everything, the procedure, you just reverse. This is actually p plus q times x power -3. You check if you differentiate qx.
No. Wait. Oh, wait.
Ah, correct. Congratulations, you have just done integration. This is a new topic. Just work backwards from differentiation. I'll explain in more details in another lesson, not today. But you don't actually need that. Yeah. Oh, -2. What am I doing? You don't actually need that for this question. I'll just leave this, box it up and move it to somewhere at the side. Not very relevant, even though it is true. Okay, so what you need to understand is the gradient equal -1 when x equals to 1. Okay. So what can you do? Can you help me to erase your?
Yes.
Yeah. So what does it mean? At 1,4, dy by dx with sub x equal to 1, this is equal to?
This is equals to -1.
-1, the gradient of the tangent. But sub x equal to 1, I think you know how to continue already, right? 1 power -3 is just 1. So there's p plus q equal -1. That's your first equation. Okay. Let me shrink it down so I have more space.
Well, then the
How about-
second one is using b.
Exactly, you got it.
b 210 dy dx. And you draw your line x equals to 2 equals to 8.
Very good.
Then you write p plus q 2 to the power of -3 equals to 8.
2 power -3 is 1
p
over 8.
plus, yeah, p plus q over
Q over 8, yeah. Okay, looks nicer. Q over 8.
equals to 8. 8p plus q equals to 6. Or actually, yeah, like that.
Yeah, it's the same. I can just use a calculator now. Let's say I don't want to use a calculator. Then I will multiply by -1. So it's -p minus q equal +1. I'll call this 1 prime. Then I'll take 1 prime plus 3. This becomes -p minus q. Add on 8p plus q on the left hand side, and for the right hand side, +1, add on 64.
70 equals to 65. P equals to 65 divided by 7. Sub P equals to 65 over 7 into 1.
So we end up with, okay, show
Q
one working.
equals to -1 minus 65 over 7.
Yeah.
It should just be 72 over 7. Negative 70.
Okay. Good. Okay, that is all. You don't need to know the y. But if let's say you did integration and you solve for y already, all right, the first step, what you can also do is to substitute x equal to 1 and x equal to 4. Then after from the point A, and then for point B, you substitute x equal to 2, substitute x equal to 10. That will also help you to form two equations involving P and Q, and you can solve for P and Q. Okay? But make sure that if you're using y, you sub in the correct value of 4 and 10. Don't sub in with the gradient anymore. I think I'll leave that as an exercise to you. You can try on your own. Okay. This the main point of this question is to test you on the concept whether you remember that dy by dx is the gradient of a tangent line. So 8x minus 6, 8 is the gradient. You need to equate to it. That's what they're testing you on. Okay. Okay, that's part 1. I'll move on. Using the value of P and Q found in part 1, find the equation of the curve. Okay lah. I mean, that we already did that. Oh, sorry. Actually, we need this for we need this working for part 2, the y equals. We found p already, right? So just replace p with 65/7 plus q is negative 72/7. You divide by -2 times x power -2. Simplify. Negative over negative is positive. 72/7 divided by 2 means 72/14. X power -2. To make it look even nicer, can bring the x to the bottom. Is that okay? Can? Yeah. That's part 2. Part 3. Show that the gradient increases as x increases. What does that mean? What increases? Gradient increases. Increases means
increasing rate.
or gradient function increases, right? How do you show that a function is increasing?
More than 0.
Of what? What is it? What's inside? Is it
X.
y? What's in between here? Is it y? If they're asking you show that the function y increases as x increases, then this will be y. But is that what they're asking you? No, they're asking for the gradient. So what function is this?
Wait, say again. If the thing is y, then it's y.
If the question asks you to show that the function y increases as x increases. This is asking you to show that d by dx of y is more than 0. Function y, then you put in y. Now the function is gradient.
Put d over
you put
dx.
in gradient. Very good. So the question mark should be dy by dx. Remember, dy by dx got 2 interpretations: rate of change and gradient function. From the first lesson. Rate of change, gradient function. Okay, now they're testing you on the ideal gradient function. I think I went through a similar question before. Gradient function, so inside is dy by dx. So this is what they're actually asking you to find. Show that d by dx of dy by dx is more than 0. But what's this? What's a faster way to write this? A more compact way.
Second derivative.
Yes, second derivative. So this is actually the d2y by dx squared. Okay. Okay, so now you know the objective. Show that second derivative is more than 0. So actually, we don't need to start with second derivative. We can start with dy by dx. We already know dy by dx is this guy, right? So all we need to do now is to replace the p and the q. What's p? P is 65/7. Q is -72/7. This is part 3. And now we need d2y by dx squared, which is the d by dx of dy by dx. So we just differentiate
216/7 x to the power of -4.
Yes, same answer. Okay. Which you can rewrite as 216/7 times 1 over x power 4. Okay, so what did they ask you? Show that this gradient function increases as x increases. So in other words, you need to show that
more than 0.
Is this true?
Yeah.
True. Why?
Because they asked to show it.
No, that's circular reasoning. 216/7 is more than 0, positive, right? Yes, of course. Then how about
X over 4, even if it's negative, even if X is negative, because it's squared by a even number, so it will result in a
positive number. Exactly. Yes. Correct. Even.
Okay.
Because even numbers you can always have 2 times something. Like for example, power 6, x power 6, you can always write it as x cubed to the power of 2. X cubed itself can be negative, 0, or positive. But when you square it, it just becomes positive or 0. In this case, could it be 0? Could this be equal to 0? That will only be true when x equals to what?
X equals to 0.
0 power 4 equals 0. But here, you must look at the original function and understand that, oh, we have a x cubed at the denominator. In order for the gradient to be defined, it means that your p plus q over x cubed must be defined. In order for this to be defined, you cannot have division by 0. To avoid division by 0, x cubed, it cannot be equal to 0, the denominator.
Okay.
Which means x is not equal to 0. Okay, so it's implied by the question. This is known as the domain of a function. What are the allowed values of x? This is not in your syllabus, it's in H2 Max. Domain of a function. Let me write this down. It's implied in this question. You don't let x equal to 0. Don't let x equal to 0. X not equal to 0. So over here, since x is not equal to 0, no. Since x is not equal to 0, that means that x power 4 is more than 0. So now that we have a 216 that's positive, or x power 4 that's positive, positive plus positive gives you positive, which is more than 0. Okay, this is a bit extra. I don't write it down. Is this clear? Right, convincing? Okay, then as a result, we have the derivative of dy by dx equals to this guy, which is more than 0. This implies that we have shown, just answer the question. Repeat the question. Show that the gradient function x increases as x increases. Just say gradient increases as x increases. Okay, that's all. Okay.
Okay.
Next question. Go. Question 4 is done. Let's move on. Okay, let's start from the bottom. Because I want to cover the question involving sign. Let's take a look at this one. This is question 39. I'm skipping to the bottom, question 39. Okay, let's take a look. So we have a circle and 2 triangles. Triangle ABO, triangle COD. The diagram shows a circular mosaic tile of radius R, cm, and center O. The design consists of 2 triangles, blah and blah. Angle AOB over here is theta radians, and angle OCD here also theta radians. Okay, it's in radians. Part 1. Show that the total area ACM square of the triangles OAB and OCD is given by that formula there.
So the total area of this and this is given by this.
Let me just give you, do you remember half AB sine theta?
Yeah. Use half. So use half AB sine theta to find this and this, and then you make it into make it like
then
this.
Together, and you get the area.
And then
half
I'll
AB
get
sine
this.
theta is the area of a triangle. Yes.
Okay.
It got cut off. What did I want to ask? The length AB is 2 cm. Oh, I can't really form a question for this. Okay, never mind. Ignore part 2.
Yeah. And area.
You need 2 sides. You don't know CD, right? So what are you gonna use? Sine rule, cosine rule? No, that's too much. That's too much. What you need is the angle over here.
It's 2 theta.
Uh-huh.
Friends,
No.
what is it?
What kind of triangle is this?
Isosceles.
Isosceles. So what's the base angle here?
180 minus 2 theta.
But we are in radians, so don't use 180, use.
Oh, I mean, 2 pi minus 2 theta.
No, 2 pi is 360.
Wait, I mean pi minus 2 theta.
Yes, correct. Pi minus 2 theta. Okay, so therefore it's half r square sine
Sine pi
r times.
minus 2 theta.
So that's when you have to remember sine A minus B. I'll write it down for you. Is sine A cos B minus cos A sine B. So what's sine pi minus 2 theta?
Sine pi minus 2 theta equal to sine pi cosine 2 theta.
I'll write it right.
Uh,
Sine pi cosine 2
2
theta.
theta minus cosine A sine pi sine 2
Correct. What's sine pi? Let me draw the sine curve for you. Up, down, down, up.
1. Is it 1?
Oops, theta. Are you sure?
Is 0?
It's 0. Pi is here. 2 pi is there. So you get 0 times cosine 2 theta, which will disappear, right?
Okay, so this
How about
is
cosine
0.
curve? Can you remember how to draw cosine curve?
Yeah.
Draw. Very good. So what's cosine pi?
This one, minus 1.
-1. But in front I already have a negative.
Yep, so we just become sine 2 theta.
Very good. Yes. Okay. So simplify the area of triangle DOC equals. Just add together. Yes. Okay. Then it becomes half r squared sine theta plus half r squared sine 2 theta. Then you just need to factorize out the half r squared 2 theta. Yes. Good. Shown. Yes. Now let's say that r is equals to, I don't know, let's say it's 1.
Yeah, r is equals to 1.
Okay, let's say
Yeah.
Ayo, sorry. Let me just take a screenshot of your working. Then I'll just send it to you. You can copy it later. And okay, help me to clear your drawing.
Wait, clear which line?
Clear everything.
Oh, okay.
Say r equals to 1. Say we fix r equals to 1. Then we want to find the stationary point of A. What does that mean? If this was the question.
Okay. Differentiate the
So
A.
r squared becomes 1, right? So it becomes half sine theta plus sine 2 theta.
Okay. Differentiate this.
And determine the nature.
Okay. dA over d theta.
Yes. Theta, not x. D by d. Your muscle memory, write down x already, cannot change that. Factor out the half first, then differentiate sine theta, you get
differentiate sine theta, you get cosine.
Bracket here, open bracket here.
Cosine theta, then plus cosine 2 theta.
What else? Cosine 2 theta. 2 theta itself is a function. You differentiate 2 theta with respect to theta, you get. It's like inside got 2x, you differentiate, you get
2.
So it should be cosine 2 theta, bracket, then chain rule, you need to multiply by
1 plus
bracket here, open bracket here. 1 plus 2, 为什么有 why got 1?
I understand.
Okay, wait, I show dA by d theta equals to half times the derivative with respect to theta of sine theta plus cosine theta, right? I mean sine theta plus sine 2 theta. So half multiplied by open bracket, differentiate sine, you get cosine.
Yes.
Okay, that's fine. But this one differentiate sine of 2 theta. Think of it as an outer function f of theta. That's sine. Okay, I better don't use theta. I use something else. And no, I have to use theta because they already use theta. So f of theta equals to sine theta. Then there's a g of theta, which is 2 theta. What we are doing is f of g of theta. We're compositing the function. So f is outside, so sine of whatever, the whatever got replaced with g of theta, which is in this case 2 theta. So there's a composition going on, a chain of functions. Right here is theta, a chicken egg, and a Pac-Man is eating. This Pac-Man's name is G, and there's a bigger Pac-Man that eats it. This Pac-Man's name is F.
So so if sine 2 theta was just sine theta, you wouldn't care. It would just be cosine theta plus cosine theta.
Yes, correct. If this was just a 1.
But cos sine theta has 2, then
So
it needs to use chain rule.
Correct, yes. So therefore the sine outside function becomes a cosine. Inside keeps the same. Right? Inside keep the same, the 2 theta keep the inner. Then you times the derivative of the inside. Keep the inside, keep it already. Then you differentiate the inside. Differentiate the 2 theta, you get 2. Done. Okay. Chain rule. Need to use chain rule. Oh, by the way, what you are saying, if you are differentiating sine theta plus sine theta, is it?
It then become 2 sine theta.
Is that, yeah, exactly. It's just 2 sine theta. Then 2 you can just factor out, leave the 2 alone, then differentiate the sine theta.
Cosine theta.
Which is 2 cosine theta. Of course, if you differentiate this one, you get cosine theta. You differentiate this one, you get cosine theta. You add them together. Cosine plus cosine is 2 cosine. 2 times cosine. Yeah. Okay. Can I must understand? This 2 theta is a inner function of the sine. So there's a composition going on. You need to use chain rule. Okay, good. So now that we have this, we can we can try to find the stationary points. For SP, dA by d theta is equal to 0. So that means this expression, half times whatever, equals to 0. But of course, half times, if there's a half times, you can essentially times 2 to both sides. Then the half will cancel away. Times 2 times 2. This just equals to 0. 2 times half cancel away, becomes a 1. Then you're just left with cosine theta plus cosine 2 theta times 2 equals to 0. How to solve? Oh no, whenever you see the angle is different, you must use special identities, right?
Mhm.
Do you recall the identities for cosine 2 theta? Three
I
versions.
thought it's in the formula. I mean,
Yes, it's in the formula. Okay, I don't need to remember, but never mind. To save time, I'll just tell you. It's cos square minus sine square theta. Substitute the cos square with 1 minus sine square. 1 minus sine square minus sine square minus 2 sine square theta. If sine square, you replace with 1 minus cosine square bracket bracket. Don't forget the minus you have to bring in. This gives you
2
cos
cosine square plus 1.
no minus 1.
I mean minus 1.
Yeah, okay. So which one would you want to use? Option 1,
This
option
one.
2, option 3. Yes, option 3, because it involves more cosines. Right? So cos theta plus 2 times of bracket cosine theta.
4
So
cosine square
cos 2 theta.
theta minus 2.
Very fast. Wait. 4 cosine square theta minus 2. Yes. At this stage, you realize that, oh, this is really just a quadratic in terms of cosine theta. You can let x equals to cosine theta. This is x plus 4x squared minus 2. Quadratic equation, you know how to solve. Use a calculator. Use a calculator.
I don't get a factorizable.
Is it factor?
I don't get a factorizable.
Then never mind. We just use the decimal approximation. So x
Okay.
equals 0.59307 or x equals negative 0.84307. But x is actually cosine theta.
Cosine. So cosine minus cosine inverse the.
How to solve? Can just cosine inverse straight away. You forgot your ASTC.
Oh.
But let's just look at the diagram first. Theta is an angle inside a triangle. What can it cannot exceed a certain angle. What is it? Can it be 181 degrees?
No.
Can it be 180 degrees?
No.
No. Can it be 178 degrees?
No.
Can 1 degree here, 1 degree here. Just make it super flat.
But it cannot what?
Why not?
It has to be less than 90. Because if this is 90 and this is 90, then this is 0.
Oh, right, you're correct. Because it's an isosceles triangle. You're correct. Yes, you're correct. Oh, I didn't see that. Okay. I was thinking in general, but this is more specific because we have isosceles triangles. Oh, good point. And of course, in order for the triangle to exist, it must be more than 0 degrees, right? Okay, very good. So that means our theta is in quadrant. Oh yeah, must be radians also. Tie over to radians. So this is in quadrant 1. Quadrant 1, very good. It means that we don't have to stress so much. ASTC, forget it.
Yeah.
Just A. Then what were you doing? Cosine inverse. Here you straight away reject, right? Because A should always be positive. Your alpha will be the same as your cosine inverse. I mean, alpha is always cosine inverse, but your theta must be the same as alpha because we're in quadrant 1. Okay, so let's just solve it. And what do we get? Cosine inverse 0.59307 approximation. So, I need to make sure it's in radian mode. Okay, I got 93592 radians. Okay? Okay, very good. So let's just convert this into degrees so we have a better gauge of what is it equal to times 180 over pi. This will be 53.624 degrees. Okay, this is extra. Okay, around 53 degrees. Then question is, when you stretch this, when you stretch this angle here until it's 53.624 degrees, is it a maximum area or minimum area? The sum of these two, the area, would it be maximized or minimized?
If you
extend the theta until it is 53 degrees. Compared to all the other angles between 0 to 90, 53 degrees is very special. It's a stationary point. So it's either max or min. How do you tell if it's maximum or min?
set dy over dx equals 0.
Sorry, set equal to 0 is to solve for the stationary point in your first step. Now I'm asking you.
Oh, just do table.
Yes, correct. Just do table. So actually, since we are learning how to differentiate cosine and sine, let's just try second derivative test. Okay, let's try second derivative test. So dA by d theta, we already got this. Now we are trying to determine the nature. Is it a maximum or minimum at that particular angle? So just take the second derivative. d2a by d theta square. That's how you read it. And differentiate. The half remains. Now we have to differentiate cosine. What do you get?
Cosine, you get negative sine.
Good.
Theta plus. I mean,
there's a factor of 2 here. Take it out first. 2 times.
Yeah.
Okay. Then you're left with cos 2 theta. Need to differentiate. What do you get?
Sine.
Huh?
Negative sine.
Negative sine. Okay. What's inside?
2 theta.
2 theta. Keep the inner function. Times chain rule.
Differentiate the 2 theta, you get 2 times 2.
You get 2. Very good. Close the bracket. Close the bracket. Okay. Let's simplify this. Negative half. Never mind. I keep the half outside. This is negative sine theta. This is 2 times negative 1 times 2, which is negative 4. Sine 2 theta. I can factor out a negative half. I mean, just a negative 1. This becomes sine theta plus 4 sine 2 theta. Okay, cool. I can't tell immediately whether it's positive or negative, so I need to sub in with the theta value I found. Theta equals 0.93592 radians. Okay, so yeah, make sure your calculator is in radian mode. So let's just type it in. Negative half times sine of 0.93592 plus 4 times sine of. Take note that this 2 theta, there's a pair of brackets around it. So you have to multiply 2 to the 0.93592. Okay, I need to close my brackets. Let me double check my work first before I. Okay, and I get a negative 2.3126. Did you get that? Can So what's the conclusion? All right, I need to find the A.
Minimum point.
Wrong.
Wait, no, I mean maximum point.
Maximum point. So A equals is maximum area. But we haven't found the maximum area, so let's just do that. Even though I didn't ask for it, just follow the same procedure every time. So half times the sine of theta plus sine 2 theta. So let's just type it in the calculator. So 1/2 times sine of, must open bracket, then sine of 0.93592 plus sine of 2 times 0.93592, close the brackets. I get 0.880086 unit square. Okay. Can? Maximum area. So now you know when you have funny triangles inside a circle, you can bend the angle to whatever angle you want. Then if you want to maximize the area, what's the correct angle? Do the death star procedure and you will figure out. And you maybe might get a minimum area or maximum area. Then in that case, you will have to figure out whether you get a max or min. How about, since we already found the maximum, how about the minimum area? What do you think is the minimum area? Like when does the minimum area happen? Like what value of theta?
No idea.
No idea. It can't be exactly equal to 0. If it's exactly equal to 0, then that would be really the minimum, because you don't have a triangle. No triangle, no area. 0. So maybe 0, theta equals 0. As you get closer and closer towards it, that could be the answer. Or it could be getting closer towards pi over 2. Then you may not have you are getting a smaller and smaller triangle. So maybe that will also help you to have no area or minimize the area. Yeah. Okay, that's just extra stuff, not so important. Okay, let's try another question. Okay, actually, before that, can we have a short 3-minute break?
Yeah.
Yeah, we'll come back after. You can go and try the other questions first. You can see which one you want me to go through. Which one do you think is more difficult? Okay. Meanwhile, I will have a short break. Haha. Come back soon. Like this.
Yeah.
Yeah, so ready to resume?
Yeah.
Okay. Which question would you like me to go through?
Try one of them with exponential. Is there?
I think don't have.
Whatever. Okay.
Sorry. Yeah.
'Cause I don't know how confident I am with the differentiating exponential.
Oh, we can try some examples. I mean,
How can
it would be-
differentiate some logarithm or whatever.
Okay, give me a second. I Let me send you a file. Let me find it first. Where is it? 15. Chapter 16. Let me take a okay. Chapter 17, right? Let me forward this to you. MX360, chapter 17. Oh no. Oh no. Let me download the file first.
Yeah.
Got the file?
Sure.
Okay, there's some practice questions there for logarithms and exponentials. We can try those first. Okay, let me scroll down. Which section is it? 17.2? Yeah, let's try 17.2. What's good? Maybe we'll just try the first 5 questions. Maybe I'll put it at the side. I'll copy it. Okay, can you see?
Yes.
This is exercise 17.2, right? Okay, let's try question 1. So, differentiate each of the following with respect to x.
Okay,
Part
I
one.
mean 1a is just e to the power of x.
Yes, exactly.
Okay.
Very simple. Just e power x. Part B, part B, 4e power x minus 6.
Differentiate. Is it not just ex?
No, because there's an extra 4 here.
ex, or you bring out the 4.
You must factor out the 4, then differentiate e power x, which is just e power x, differentiate minus 6, you get 0. Done.
Okay.
See ya. D by dx of x times e power x. This one. Multiplication going on. Product rule, right? So
Okay.
keep 1 x.
Differentiate the other one, which is just ex.
Plus ex.
Plus 1 times ex.
Yes, correct.
So this will be
factor our
x
e power
plus
x.
1 times
We'll get
ex.
x plus 1. Yes, very good. Part D, e
Mm.
power x over x. Something
Low
on
D
top,
high,
something below.
less high. Low D high, less high D low, square the line. Wait,
Draw
the
the
line
line.
square. Draw the line square below.
You cannot square a line. Low is bottom, D high means differentiate the e power x. Just e power x. Less, minus. High, e power x. Below, times 1. Draw the line. Square
X
below.
square.
Done. Then you're left with e power x times x minus 1 over x squared. Done. Okay. Okay, not too bad, huh? Okay, let's try the next one. Question 2, I need more space. Okay, question 2, with differentiate again. So this time we got e power negative 2x equals
e power negative 2x
times chain rule
times negative 2.
negative 2, exactly. Yeah, that's it. Easy, right?
No.
Yes. D power x is the easiest one already. I'll say yes very confidently. Yes, of course. So easy.
Bring out the 5.
So
Yeah.
5 times derivative of inside. If you're faster, you can skip this step and go directly to the
e
final answer.
power 3 minus 5x times negative 5.
Negative 5, very good. Differentiate 3, you get a 0. Differentiate negative 5x, you get negative 5. 0 minus 5 is negative 5. Well done. Simplify, you get negative 5 times 5, 25. E power 3 minus 5x. Okay. Okay. Next, part C. Differentiate e power 3x plus 7. Too simple already. No?
E power 3x times 3.
If you're fancy, you can always put the 3 in front. Then you can make it look nicer. Don't need to put our times. Differentiate 7, you get a 0. And of course, you don't need to write it. Done. Good. Next, part D. Differentiate e power x plus e power negative x.
Okay. E power x plus negative e power x.
Wrong. E power what? Oh, negative x. Sorry, maybe I heard you wrongly. The power must keep the same. Your first step, maybe you should copy and paste. Then after that, you differentiate the power. The inner function is the power. Differentiate negative x, you get negative 1. Multiply. Okay, I think it's easier if you just put it like this. Follow the procedure for chain rule. Don't get confused. So don't get unnecessarily confused. This is getting the correct answer is more important than doing it fast for now. Okay, then part D is done. We try question 3. Let me copy the question over first. Now it gets a little. Give me a second. Okay, now it gets a little bit more difficult. So question 3, in each of the following, use the rules of indices to express y as e to the power of ax plus b, where a and b are real constants. First step is to convert into this format. Step 2 is to find dy by dx. Okay, so first one, y equals to e to the power of 3x multiplied by e to the power of x minus 1. Same base, different power, multiply. What do you do to the powers? Plus or minus?
What do I do to the powers plus or minus?
Multiplies best friend is? Plus or minus?
Multiplies best friend is plus.
Divides best friend is?
Minus.
Minus. Okay, so 3. Here got 3x, here got x minus 1. The base is the same. You have a multiply.
Okay. 4x minus 1. E to the power of 4x minus 1.
3x plus x minus 1. Because multiplication's best friend is plus. Then it becomes a 3x plus 3x, which is 4x minus 1. Good. Therefore, dy by dx is?
Therefore, dy by dx is e
First
to the
step,
power of
copy,
4x
paste.
minus 1 times 4.
4, exactly. Easy.
Or
Next.
4e. Oh, yeah. Okay.
Can also rewrite it as 4e power 4x minus 1. Can. If you want, you can even rewrite it as 4 times e power 4x. There's a minus 1, so e power negative 1. Bring down. So it becomes over e. That also works. Okay. Part B, let's try y equals e power 2x plus 3 divided by e power x. Oh no, so complicated. Need to use quotient rule, is it? You can use quotient rule, but not
Just bring
advisable.
up.
Because, yes, just bring up. So this is just e power 2x plus 3. Divides best friend is minus. So you just minus
x.
I purposely put in the brackets because if I change this into x minus 1, what happens? If it's minus 1 here,
Or
you
then
also
the
need to have
negative need to
minus 1 inside the bracket. And then the negative need to be changed into plus. Okay. Invisible pair of brackets, but of course that's not the question. Let's just keep it as this. So simplify, you get 2x minus x is x plus 3. dy by dx will be?
dy by dx will just be ex plus 3.
Yeah, correct. There's a 1 here, you can times 1. Don't need to write lah, huh? Obvious. Okay, good. Part C. Y equals to e to the power of 1 minus x bracket power 2.
Okay. Times, that means it's just e to the power of 1 minus x, then e 1 to the power of 1 minus x.
Yeah, correct.
Product
I
rule.
hope actually product rule. You see you've defeated the purpose of the question. They wanted you to use the exponential rules. Do you remember a power m bracket power n is just a power m times n?
Oh, so 2 minus 2x.
Yes, correct.
Okay.
Or you can think of it as addition, right? Multiplication, then it just becomes addition. So 1 minus x plus 1 minus x is just 2 minus 2x. Then you differentiate. Okay, later I show you product rule, how to, it will still work, it will give you the same answer. Okay, let's just differentiate this first. First step is the easier step. You just
copy paste 2 minus 2x, then differentiate on top, so negative 2 times negative 2.
Very good, that's your answer. Okay, now let's try it using the long-winded product rule. Wow, product rule for this one a bit overpowered. But anyways, dy by dx, if you use product rule, keep one, differentiate the other, differentiate e power minus x, copy and paste, times a negative 1 chain rule. Not enough space. Let me shrink it down a bit. Sorry. Have to squeeze a bit. Okay, I can see y'all. Right. Keep one, differentiate the other, plus keep the other, differentiate one. Of course, it's the same, huh? Right? Because these two guys are the same. Let's simplify it now. So e power 1 minus x times e power 1 minus x times a negative 1. I'm just going to put the minus in front. I don't need to put the 1 there. It's implied. Same thing for the other guy. Minus the same thing. Negative 1 goes in front, becomes a minus. So now you have e times e power something times e power something. Same base, different power, multiply, add the power. So you're left with minus e to the power of 1 minus x plus 1 minus x. Same thing for the other guy. I'll just copy and paste. Of course, at this stage, you should realize it's just 2 minus 2x minus e power 2 minus 2x. Right? This guy is like capital X, and this guy is capital X. Minus x gives you minus 2x. Can you see the screen? Am I talking?
Yep.
But of course, it's not actually x, it's e power 2 minus 2x, which is the same answer as what you got here. Can? So do you want to use power rule or do you just want to use exponential?
Exponential.
Use your rules of exponential, laws of exponents, and then you proceed to differentiate. Don't go and do product rule unnecessarily. You waste a lot of time. Okay, but it works. It works. So that's the good thing about differentiation. A bit more flexible. Okay, now for part D, let's try y equals square root e power 3x. What's this equal to? E power?
Power 3x over 2.
Yes. This is implied to be a square root, but it will not be written. So dy by dx will be equal to?
Copy paste.
Copy paste.
Then differentiate the inside times 3 over 2.
Very good. Yes. That's it. You get the pattern now? Copy paste, differentiate the inside. Copy paste,
Yeah.
differentiate the inside.
Okay, but
can.
then it's different when you put it with the
Ix.
logarithm
One.
and then you put it with the
Sign.
logarithm and then you ask me differentiate.
Okay, then we will try that now. Let's try question 5. Let's just go straight to question 5. Product rule and chain rule. Is it too small? Can
No.
see? Okay, let's try this now. X plus 1 times e power 2x. Okay, I'll go through this one quickly. So for this times this, you see that it is product. So you can just take one, differentiate the other, differentiate e power 2x, you keep it, then you differentiate the 2x. So you get a 2. Plus, take the other, e power 2x, multiply by derivative of the first. Differentiate x plus 1, you get a 1 plus 0. Right? Which is really just 1. So plus e power 2x times 1 is just e power 2x. This part, there's a 2 times x plus 1 e power 2x. Common factor e power 2x, take it out, you're left with 2 bracket x plus 1 plus 1. Simplify a bit more, e power 2x times 2x plus 2 plus 1, which is plus 3. Okay? Okay, part A is done. Let's try part B. Part B is y equals e to the power of negative 2x times sine x. Try. Your turn.
It's not the same thing.
It's the same. Product rule.
Okay. Okay, copy paste e minus 2x.
Are you writing?
I'm trying to, but I don't know why it's not writing. Okay, now it's writing. E 2x. Then we get this to the
Good.
times sine x.
Perfect. That's it.
Okay.
Yeah, that's all. You can factor out the e power negative 2x. One more set.
Yeah.
Minus 2. Okay, factor out the e power negative 2x. Yeah. Okay, good.
No.
And then if you want, you can also bring it to the denominator. The minus 2x.
No, but it's not the same when you put with like the ln, then you put with the I don't know exponent, you put I don't know sine or tangent, and you put all together.
Yeah.
It's like
Yeah, it's a lot more messy. Yeah. That example, I was just trying to squeeze everything into one. Okay, but yeah, it's a bit too much. Okay, part C, yeah. Y equals x times e to the power of x cubed plus 2x. Oh no, we have a x cubed on top. Should I demonstrate or you want to try?
Okay. dy over dx equal to k product rule. So keep x first, then bring this copy paste, differentiate on top times
Open bracket.
x square plus 2.
Okay. Oh, yeah, you try to keep the times bracket 3x squared plus 2 a bit lower. Yeah. I'll put a square bracket, yeah. If not, you confuse with the exponent. 3x squared plus 2 must be on the same level as the e power. Okay, can.
Plus times 1, then copy paste ex plus 2. Then can factor out the e to x give you 3 plus 2x plus 1.
Okay. Can. Yes. Or you multiply the x into 3x squared plus 2, get 3x cubed plus 2x. Yes. Yes. Can. Good. Let me just take a screenshot. Okay, I'll send you and then we'll move on. You will copy it on your own. Okay. Oh, okay, can move on. Next example, e power 1 minus x cosine 2x. You want to try or I demonstrate?
I try.
Okay, try. Go.
Okay, product rule. Copy paste. Wait. Copy paste. Okay. Times cosine 2x. Differentiate become negative sine 2x. Then cos this is a 2. Then times 2.
Yeah, exactly.
Okay.
Put a pair of brackets around sine 2x. Minus open bracket sine 2x close bracket. Yeah, that works too. Yes. Plus
10 times minus 1.
times minus 1, yes. Very good. Yeah. You can factor out the you can also factor out minus sign.
Oh, wait, yeah.
Oh, your audio is getting very soft. Mic test.
Yep.
Okay, can you still hear me?
Yep.
Okay, can. Yes, this is very good. Very, very good. Okay, can. All right. Oh, wait, one more challenge. Can you express this purely in terms of sin x? Trivial identity.
And I express this purely in terms of sin x.
Only sin x, not
Yeah.
2x. Okay, wait, I need to show you the identities. Sine of 2x is 2 sine x cos x. Cosine of 2x can be cos square x minus sine square x. Or substitute cos square for minus sine square, you get 1 minus 2 sine square x. Substitute sine square for minus cos square, you get 2 cos square x minus 1. Yeah. Yes. Okay, then sine 2x. Okay, no choice. The cosine x will remain. You have to keep it there. Okay, yeah, okay, that's just an extra exercise, not so important. But in case you need to know that, just keep in mind your trigo identities. You will still need to know those things. Okay. Okay, let's try more examples. Let me see if there's logarithms. Yeah, have. Okay, revision exercise. No, I wanna try logarithms. This question 7 looks okay. Let me just bring it down. Question 7. Okay, where's my question 7? Okay. Where is question 7? Here. Okay, let's try question 7a. Shall I demonstrate first?
Yeah, sure.
Yeah, so part A, the key is to realize that you have logarithm and a square root. So that means square root, you can rewrite it as, before you differentiate, you can rewrite it as power half. So when you have power, you can just bring it in front. So would this be equal to 3x times half ln of this guy, then I minus 1. Correct? Bring down the old power minus 1 to get the new. Yes? Wrong. Wrong. How's wrong?
That one is differentiate.
Yes, here I'm still writing y equals not dy by dx yet. Haven't differentiated yet. Very important common mistake. Please remember. Bring down, just bring down. Don't minus 1. Do not minus 1. Not power rule. We are not using power rule yet. Okay? Good. Next. Why do I want to do that? Because now we have 3 over 2x times ln of whatever. It's easier to differentiate. Proceed to differentiate dy by dx. 3 over 2, just factor out, leave it alone. Then now you got x times ln of something. Then you have to use your product rule. So let's just do product rule, keep one x, keep the x, differentiate the other. Ln becomes what? 1 over, right? Whatever is inside, copy and paste. Okay, whatever is inside, copy and paste. Go to the denominator. Then you multiply by the derivative. So differentiate x squared minus 2x, you get 2x minus 2 minus 0. If you want, you can always bring it up to the numerator. So you get 2x minus 2 minus 0. Minus 0, don't need to write. Like this. Plus, take the other, which is the ln. Keep the inside. Then multiply by derivative of x. Remember, I've already factored out the 3 over 2. So I'm only looking at x and ln. So maybe I should put a pair of square brackets like this. Hopefully it's clearer. Then times 1. Okay, is it clear? Okay, good. So now we get 3 over 2 times all this. Actually, I'm not going to simplify this. This is good enough. Don't need to simplify. Can? So, okay. Let's try. We must try an example. Let's try part B. Part B, y equals ln of, wait, don't write yet, sine x cos x. Go.
Wait. I want to see it on top again. Or like last time. Wait.
So what thing?
Yeah, I just want to see again.
Oh, okay. Let me try and squeeze everything on one page so we can see it. Just from PNC. Let me shrink it down a bit. Oh no. Oh no. Wait. Okay, I'll put it here. And this one. Ayo. Oh no. I can't move it. Okay, never mind. Like this. Okay, then start. Go. Try. Puppy. Oh, right. I should write this down in general. Differentiate ln x, you get 1 over x. Differentiate ln of f of x, you get 1 over f of x. Then you multiply by the f prime because of chain rule, which is really just f prime of x over f of x. This is just chain rule. Also, you only need to remember this first one. This is just an application. Don't stress yourself out with memorizing so many things. Just remember this one. Yeah, so ln of whatever is inside just goes to the bottom. Whatever is inside, just go to the bottom.
Yep. On top over down.
Then now whatever is inside, differentiate.
Minus sine x.
Good. Yes, product rule, right? So your make your fraction a bit longer. Oh, sorry. A bit longer. Then you continue. Numerator is different derivative of this product, so you need to use product rule. Sorry. Do you get what I'm saying?
Wait. Okay, yeah. Wait, yeah.
This part is your f of x.
Wait, oops. Okay.
Something is wrong with your first term.
Wait.
You differentiated both. Cannot. Cos x minus sin x. Wrong.
Wait.
Okay, I write down for you. Differentiate sin x is cosine x. Differentiate
No. Cosine x is negative sine x.
Sine.
Differentiate negative sine x is negative cosine x. Differentiate negative cosine x is sine x.
Yep.
Wait. Okay.
Don't stress about the negative version. Just remember the positive sin x and positive cos x version. Negative is just an extra negative one factor. Okay. Minus. Yeah. Minus become plus. I'm sure you know that. Only remember these two. That's all. This, and this. Then of course, if the x become fx, then you just have to chain rule. Keep one, differentiate the other, plus keep the other, differentiate one. Much better.
Cosine square x.
Yeah. Yes.
Then how?
Then that's it. That's your answer already. They never ask you to simplify further. Your first term just now, you differentiate wrongly. Sin x times negative sin x is better. So negative sine square. I see a pattern. Okay. This guy becomes 1 over sine x cos x. Keep one, differentiate the other, plus keep the other, differentiate one. You get cosine. Of course, cos times cos is cos square. So that means that we end up with cos square x minus sine square x. Can you see that? Does it sound familiar? Cos square minus sine square is cosine 2x. Okay, but sine x cos x is 2, you can times 2 times half. This part here is half times of don't remember, sine 2x. Oh, okay. Then this is cosine over sine. Okay, the half can go up, so it becomes 2 cos 2x over sine 2x. Which means cosine over sine is cotangent. If the question ever asks you to show that it is cotangent, then you have to do this. Do a bit of trigo identities. Okay. Okay, can let's try more examples. Go. I'll see more examples. Part C, y equals to ln of 3 plus e to the power of negative half x. So is this equal to ln 3 plus ln e power negative half x? Then ln and e cancel away at negative half x. This is the ln 3, just a constant. Then you differentiate constant, you get 0, negative half factor out. This is just x power 1, so it's just negative half. Then the answer is negative half, correct? Correct or wrong? Got plus, just split. Can?
Okay.
Cannot. Oh, I forgot your logarithms. It's a trick question. Logarithms can only split a product into a sum, not a sum into product. Ln A plus B is not ln A plus ln B. Okay. Just try with a quick example, like ln of 2 plus 3 versus ln of 2 plus ln of 3. You type in a calculator. Wait, I have a calculator. I can show you straight away. Okay, let's see. So ln of 2 plus ln of 3, 1.791. Okay. Now we try ln of 2 plus 3, which is ln 5. 1.609. Are they the same? No, clearly, you cannot split into 2 plus 3 into 5. I mean, you cannot split the 5 into 2 plus 3 and distribute the ln. Okay, no such thing. Please remember that this is nonsense. No. Okay, can So how do you actually do it? How do you actually differentiate this? Follow the rule. You see ln open bracket, blah, 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 close bracket. Treat this as one lump. Then what do? Differentiate ln, you get 1 over, right? Maybe I should copy all this down so you can have a reference. Here, and these two. Got one more, tangent give you secant square. Yeah, you need to memorize these 4. One more, differentiate e power x, you get e power x. Okay. Carry on, try. What's different derivative of ln of 3 plus e power negative half x? Mic test, am I still connected? Oh no.
Yeah.
Okay, yes. Thinking.
Ln 1 over
Write it yourself.
1 over 3 plus
Good. But this one, change to fx. Then that means you need to use chain rule, right? So you still need
Yep.
times.
differentiate then bring to the top.
Yeah.
Which will just be e minus half x.
Copy the power, then times.
Then times minus half.
That's it. Done. Correct. See, one line only. So simple. Okay, yeah. After some practice, it will become a lot simpler. Is that okay?
Mm-hmm.
Can I? I'll put ... You try again on your own. Let's see the other example questions. D, E, F. Okay, let's try question. Okay, what's the number? Question 7. Hey, actually, what's the exercise? I didn't record down. I think it's 0.3. Exercise 17.3, question 7D. Let's go. So, ln of, wow, so scary. Don't worry, it's just 1 over, right? Can you split the ln of this minus ln of this? Yes or no? Can you split it up as ln of square root whatever minus ln of x?
No.
No, not equal. So please do not do that. Don't split over a sub minus or a plus. So carry on. How do you find dy by dx?
Copy paste 1 over the whatever thing first.
Good.
Yep.
I'll copy and paste it for you.
Then differentiate that one, then bring to the top, which
Yes.
wow, okay, wait. Change this. Okay.
Square root is power half. Yes.
And minus x.
Yep.
Yeah.
So differentiate. Got power half.
Differentiate half. Bring down x squared plus 1.
Copy the base. Good.
Half. Differentiate inside 2x
Good.
minus 1.
Very good. That's it. Okay, pause before let me. Okay, help me to erase whatever you wrote down.
Yes.
You are correct. But now, usually what happens is we want you to clean up the answer. So here, whenever you see negative power, just like when you're doing product rule, you must factor out the lowest power. Bring down also can, same idea. So you just have to, let me think a bit. Just do an extra step.
Wait, you don't need to
yes.
times 2x here.
Times 2x. Sorry, yes, you're correct. I made a mistake.
Oh, okay.
Oh, right. There's a 2.5, then they cancel away. Sorry, didn't see that. Oh. Too fast. Yeah, then after that, you all divided by square root minus x. Like this. Then, wow, this one got a -1. Very irritating. Means I have to minus x squared plus 1 power half over x squared plus 1 power half. Right? Then I can combine it into a single fraction. 1 minus x squared plus 1 power half all over x squared plus 1 power half. All over square root x squared plus 1 minus x. And this one can go to the bottom, which will become 1 minus x squared plus 1 power half all over the denominator here, bracket, multiplied by this expression here. Maybe I'll highlight it. Blue, blue. Okay. Yeah. Okay. Interesting. Then you can rationalize the denominator if you want. But I think that's a bit too much work. Don't need. Let's try another example. See more non-examples. Okay, so what we have seen just now was whenever you have ln of a plus sign in between, you don't split up. When you have ln of a minus sign in between, you don't split up. But now we have question 7e. ln of y equals ln of e squared times 3x minus 2 over 4 minus x. There's a fraction going on here, which is division. Can we split up before differentiation?
Can you split up before differentiation?
Recall your logarithms many months ago.
I mean, can you? Yeah, I mean, you can make it to minus. You can make it ln e squared 3x minus 2, then minus ln 4 minus x. No.
Very good. Yes, exactly. Different. This one finally is a legit splitting. This is true. This is correct. Okay. You can split a division into a subtraction. A division into a subtraction. Let me just put a pair of brackets here to make it more, to emphasize that the numerator is inside the argument of the logarithm, ln of the numerator. Okay, then becomes a minus. What's so good about this? What's so good is that you can avoid quotient. Avoiding quotient rule and product rule is a very good thing. Okay. Agree or not? Right? You don't want to do product rule and quotient rule. Avoid them as much as you can. So we proceed to see if we can split further. And you realize actually we can. This is e squared times 3x minus 2, right? So can we split further? Times?
Plus.
Becomes a plus.
Square plus ln 3x minus 2 minus ln 4 minus x.
Wow, so simple now. You just need to differentiate term by term. But ln e squared, we can go a bit further. Power 2, what do you do?
Bring forward.
So it becomes 2 times ln e. Then 2 minus 1. Is that correct?
No.
Correct, what? This is e power 1.
I mean,
then it's the same.
It's a coincidence.
It is a coincidence. Very good. It is only a coincidence that it is the same. More importantly, what's ln e?
What is
What's
ln e?
Ln e
is 1. So
very
2
good.
plus.
So 2 times 1. Not plus. 2 times 1.
Right.
So it's 2, right? Plus ln 3x minus 2 minus ln 4 minus x. Wow, so simple now. How to find dy by dx? Differentiate term by term. Differentiate 2, what do you get?
You get 0.
Very good. Next one.
Three x 1 over 3x minus 2
Times.
3, which is you just bring to the top.
So to make it look neater, I can bring it to the numerator.
Then minus
Minus.
minus
say 1
minus 1.
Okay, yeah, correct. Don't actually, I recommend you to just think of it as 1 over. Just memorize it. 1 over first. Then after that, you times and you bring it up. Okay. 1 over 4 minus x, then times the derivative of 4 minus x, which is -1. -1 bring up to the numerator. Okay, and then we are done. Of course, minus, if you want, you can change it to plus. So what you learn from this is that logarithms help you to simplify the derivative a lot. Okay? Can understand? So now that we learned this trick, let's try one complicated extra example. Let's say that you have y equals to what is it? 5 minus x power 3 over 2, and then you got x power 2 over 3 plus 2x power 7. Wow, so complicated. You want to differentiate. You have to use what rule? A fraction. Use.
You would have to use the opposite of product rule.
Quotient rule. Quotient rule.
Low D high, less high D, low square the line, draw below. I mean,
Ah.
draw line square below.
Draw the line and square below, right? But maybe, okay, just to make my point a bit clearer, I have to simplify the question a bit. I don't want the minus sign. Plus sign, wow, also a bit difficult. Let's say I change it into square root of this guy plus 1. Okay, can. In this case, yes, use quotient rule. But then, of course, there's a trick, which is the logarithm trick, where you log both sides of the equation first. So we take ln y and ln of the fraction. I purposely redesign the fraction so it's multiplication going on and a division going on. What's so good about this is that we can now split it up using logarithms. I hope you know this trick. Numerators become positive. Denominators become negative. The denominator has a multiplication going on here, x power 2/3. So I can have x power 2/3 here, square root 2x power 7 plus 1 over there. Can you see that? I skipped a few steps for the logarithm rules. Is it clear to you? Do you want me to explain?
No need.
No need, Okay, good. So then we can proceed further because ln of a product over here, we can split it up further as same thing as what we did. Ln 5, ln x power 3 over 2. Then here got
Bring
power
down.
3 over 2. Bring down, need to minus 1. So become
Hell
half.
no. Nope.
Absolutely not. Please do not do that. Very good. Power rule and logarithm rule. Please do not confuse between them. Next one, minus ln this one, 2/3. Hey, can you still bring down? Do you need to minus 1?
No.
Do not bring down. Do not minus 1. Sorry, you do bring down. Do not subtract 1. Yeah. Okay, good. Next one, same thing. There's a power half, right? I hope you remember that. X power m over n is the same as x power of m, and you take the nth root like this. Okay. Okay. So in this case, power square root is actually an invisible half. Ayo, handwriting very bad. Let me change it a little bit. Okay, so just take note that the square root typically we will not write the 2 for the root over there. Okay, it's implied. So anyways, this one, root means power half. You can bring down the half. Do you need to minus 1 to the power to get negative half?
No.
No. Can you split this further up into a sum? Can you do that? Distribute the ln.
No.
No, cannot. You can only take a product inside, split into sum. Not sum into sum. Sum into sum, not allowed. This is banned. No. Okay. But anyways, now that we have all this, on the left side, we got ln y. I think you remember your implicit differentiation. How do you differentiate now with respect to x? Left side. Differentiate ln, you get 1
over y.
Y. Very good. Then times, don't forget, chain rule.
Times.
Treat it as a equal ln y. Do you want to differentiate with respect to x?
A equals ln y, differentiate. Then is it not just like 1?
Huh?
I
No,
mean,
no,
you
look at this. What do you want? D what?
dy dy.
Y. So it's dy by dx. This part here is this part here. Can you see?
Yeah.
Okay now? Good. That's the left hand side only. Only 10% of the work done. Now the other 90%. Okay, I just get rid of this.
Okay,
Toss it
1
aside.
over 5.
Yes. Then ln 5 differentiate. What do you get?
1 over 5.
1 over 5. Ha 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 ha. Yeah, no, 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 no. 1 over x when it's a variable involved. What's ln 5? Ln 5 is just a number. It's a constant.
Oh, 0.
0. Okay, I put a 0. This one, the 0 is important. Not 1 over 5. No.
Plus
Okay. 3 over 2 factor
over
out.
2
Then times.
divided by x. Times 1 over x.
1 over x, which is divided by x. I'll just write the standard format. 1 over x. Minus 2/3 times.
1 over x.
Very good. Minus half times. 1
Okay,
over
1 over 2x to the power of 7 plus 1. Then differentiate 2x to the power of 7 plus 1 put on top. So 14x to the power of 6.
Yeah, exactly. Okay, then put on top, so it's just 14x power 6. Ta-dum. Okay, good. Almost there, almost got the final answer. We want to solve for dy by dx. All we need to do is do times
y.
So bracket times y, but y is actually whatever we found here. So you sub in and then we are done. You can imagine, I hope you can see how this is a lot easier to do compared to doing quotient rule, right? On this monster. Low D high, less high D, low draw the line and square below. Possible, but very long-winded. Okay, this is known as implicit differentiation with logarithms, or what they call, if you Google online, logarithmic differentiation. Logarithmic differentiation. Just a special trick. You take ln on both sides, then you differentiate as per usual. Left-hand side need to use implicit differentiation. Right-hand side is do some logarithm acrobatics, and then after that you differentiate. Yeah, that is the purpose of logarithms. It helps to simplify things, helps to simplify derivatives with that implicit differentiation trick. Okay, next one, part F. Let's try. Go. X plus 2 power 3 cosine 3x over sine x. Wow, they are making your life very difficult. Okay, carry on. Let's say we don't use logarithm tricks and we just do it directly. Let me just quickly demonstrate to you how to do it. dy by dx. You see ln, just 1 over. 1 over this guy, but it's a fraction. 1 over is the same as taking the, you remember your gradient of a normal, negative 1 over, and reciprocal, right? It's just reciprocal. Flip the fraction around. So that means I can take a shortcut, sine x on top, x plus 2 bracket power 3 times cosine 3x below. Okay, that's the 1 over x part. Reciprocal, flip.
Then differentiate the top.
And times the derivative of, no, in this case, not differentiate the top. Differentiate and then bring to the top. So bring to the top is actually very extra. That one is just algebra, you know already. What you need to learn here, the new thing is differentiate the inner argument of logarithm. Ln of x, you differentiate, you get 1 over x. Ln of f of x, differentiate, you get 1 over f of x.
Times
right, just
f
bring it to
prime
the top,
x.
and times f prime x. So you see the pattern, it's always just times f prime x. Let me write it down again for you for all the others. Y equal to sine x, differentiate dy by dx, you get cosine x. But if you change it now to y equals to sine of f of x, differentiate is just cosine of f of x. But don't forget to times f prime of x. The times f prime of x is just an extra step because of chain rule. Oh, likewise for the others, if y equals cosine x, differentiate, what do you get? Negative sine of x. Need to memorize. Y equals to cosine. Now we upgrade to cosine f of x. Then you differentiate, what do you get? You get negative sine. Inside keep the same, but you need an extra times f prime of x. And just list down everything, y equals e power x, differentiate stays the same. Y equals e power f of x. Let me just write it in a different color, blue color. Then dy by dx will be copy and paste the same thing. But you need extra times f prime of x. Do you get the pattern now? You see the pattern? So if it's y equals to 1 over x, dy by dx equals to ln x, correct?
Yeah.
Correct. Oh no. What's wrong?
No, not correct.
What's wrong?
That's wrong.
This one is x power negative 1. How to differentiate power?
Minus x to the power minus 2.
Exactly, not ln x, right?
It's flip around.
Yes, other way around. Don't get confused. Later, when we do integration, we're gonna work backwards. I hope you're not confused. Okay, anyways, so if y equals to ln of f of x, now change from x to f of x. What's dy by dx? Just 1 over f of x, right? Just change from x to f of x. Then don't forget to times f prime of x. Can you see the pattern now? Every time you add in extra nonsense, you just have to times the derivative of the inner function. So let's take a look at this question now, directly without using any logarithm tricks. If you really forgot your logarithms, just remember 1 over, which means you flip the fraction around. Then you multiply by derivative of the inside. So this monster, you can go and differentiate it. D by dx of, okay, I'm beginning to regret doing this. Oh no, so much work. Need to use quotient rule. Wow, how? I'll just say 1 over x, flip. This one, okay, never mind. I have an iPad. I can copy and paste. It's pretty fast. So copy and paste the first fraction, then differentiate this guy. So you see a quotient, you have to use quotient rule. So bottom square first, and bottom the top, which is 3 times x plus 2 power 2 times 1. Don't need to put the times 1. I'm running out of space. Differentiate the first. Oh, sorry. I realize this is a low, D, high, and this is a product. So I have to use product rule again. So I am running out of space. I need more space. Can you just give me a second? I'm going to bring this working down now. Okay, if you forgot your logarithms rule and all you remember was 1 over x, here is how you would do it. You have to differentiate this expression manually using product rule. Quotient rule and product rule. So low D, high, less high D, low, draw the line at square below. Sin x, keep it, differentiate the top guy. So let's say I differentiate the first guy, then I'll keep cosine 3x. Plus, I'll keep the first guy, then I differentiate cosine 3x, which is negative sine 3x. But what else is missing? I still need to times. Are you following?
Yes.
Still need to times?
Still need to time. Yeah. But then
Times what? Times what?
Is it 3?
Yes, because 3x, chain rule. Okay. Is it clear? That was only the low D high. Maybe it's clearer if I just swap the order. I don't know if it helps. It's the same. Keep one, differentiate the other, plus keep the other, differentiate one. Okay. But that was just low D high. Not enough. Still need to less high D low.
Yeah.
Correct. Repeat. Low D high, less high D low. Draw the long line and square below. So you can see how if you don't use your logarithms, you don't remember your logarithms, you're gonna have a very bad time. Less high D low. High is what? High is just this one. X plus 2 cubed times cosine x. And times, need more brackets in case it's confusing. D low, differentiate sign, you get cosine x. So please take note that cosine 3x and cosine x, you can't really interact with them. You can't really directly add them together. It's not cosine 3x plus x, which is cosine 4x. No, it's not that simple. There are special identities for it, factor rule, but it is not relevant now. Anyways, this is the answer. Okay, this is the answer. Very long-winded, not recommended. What you need to do instead is bad, though correct. Sorry, it's slow. So here is the recommended way. Use block rules. Then differentiate. Log rules on y. Sorry, let me make this clear. On y, then you differentiate. So try the question again, but this time with the more efficient way. Y equals to ln of whatever. What do you think is the more efficient way? How do you do it?
You separate it.
Separate. How? Tell me.
3 ln x plus 2 plus ln cosine 3x minus ln sine x.
Very good. Okay, you remember your logarithm rules. Then dy by dx?
Dy by dx 3 over x plus 2 plus 1 over cosine 3x times wait, let me think. Negative sine 3x times 3.
Good.
Minus 1 over sine x times cosine x. Yeah.
Very good. Yes. Let's just clean this up a bit. So we get x plus 2, 3 on top, plus this is negative 3 sine 3x over cosine 3x minus cosine x over sine x. Okay, good. So how do we check if we are correct? You can type this entire thing into decimals and put y equals. You can type this entire thing here, type y equals in decimals. And if the graph looks exactly the same, then it means that they are the same. Okay. Alternatively, you can say you type this entire thing here, then minus this entire thing here. If you get equal to 0, means you get if you draw the graph, you get sorry, x-axis here, y-axis here. You get the x-axis, then you are confirmed correct. You subtract them and you get a 0, it means that for all x values, those two expressions are equal. Okay, but I'm pretty sure this answer is correct. I am not going to check on decimals. All right. Okay, good. So I have tried many logarithm questions. Let's see if there's anything else that's important. Revision. It's okay lah. Not that important. Maybe I will try one more question from the rate of change one. Let's see what's good. What is good? 23, yes. Standard question, but it's on surface area. Okay, let's try this question. Okay, let's take a look. So what we have is a cone on top and a cylinder below. Okay. The diagram below, it shows a solid body which consists of a cone fixed to the top of a right circular cylinder. Right means that it is not like a slanted kind of cylinder like this. No. Right means that the top here and the center of the circle here, they are along the same dotted line, right? Along the same perpendicular. You can imagine this 90 degrees here. Oh, okay. Yeah, so it's directly above. Good. So radius r and height hcm. So radius r you can see here, height hcm you can see there. Given that the slant edge of the cone is 3r, this part is 3r. Part 1, given that the volume of the cylinder is 108 pi cm cubed, express h in terms of r. Okay, so volume will be made up of volume of cone plus volume of cylinder, right? Okay, what's the volume of cone? 1/3?
1/3 pi r square
times
height.
Do you have the height? Is it
R.
h? Is it h? Is it r?
Is h.
Wrong. H is the height of the
R. Right
cylinder.
circular.
R? No. Labor, where is the height of the cone? Use your D&T skills.
Height of the cone. We don't have.
And let draw, you must imagine. Engineer, you must be able to imagine your own height. I already essentially drew it for you.
Pythagoras theorem.
Very good. Where? Pythagoras theorem, what kind of triangle do I need? Can you draw for me on the diagram? Draw the triangle. Yes, correct. Okay, let's just give it a label. Don't just draw question mark, use a letter. Let's say L. Let's say L, for example. So let's just use a highlighter like this. Can see? Yes. So therefore, let me bring the working to the side. So L square plus, clearly this one is R. R square equals to 3R square, correct? Wrong. What's wrong? Missing a pair of brackets. Please take note. 3R square is not the same as bracket 3R square. This is 3R times 3R, which is 9R square. Okay, 9R square. This is 3R square is the same as 3 times R square. Just take note of the brackets matters. Okay, so anyways, L square plus R square equals to 9R square. So therefore L square equals to 8R square. Just subtract one copy of R square. 9 apples minus 1 apple gives you 8 apples. Then L equals to plus minus square root 8R square. Do we need the minus? Don't need, because L is always Hello, are you still there?
Positive.
Length is more than 0. Okay, very good. So that is square root 8r squared. Can? Can? Okay, good. Then this will be square root 8r squared. Let me change the font size. Okay, 8r squared. Good. That is volume cone. Not enough. You still need to plus volume of cylinder. What's volume of cylinder?
Volume of cylinder. Square times height.
Pi r squared, the base area, times the height, h. Okay? Good. But what else do we know about the volume? Total volume, what did they say? Is?
1085.
So you can just fill in the blank with 108 pi. Okay. Is it clear? Can? Then what's the objective? Express what? H in terms of R. Where do you see H? Over here, right? Everything else is in terms of R and numbers. Then you can just make H the subject. So let's just make pi r squared the subject. Pi r squared H the subject first. So we get 108 pi. You subtract away 1/3 pi r squared, square root 8r squared. Is it clear?
Divide by r.
Pi r squared. Okay, not enough space. Give me a second to move this down. Yeah, so I need to make H the subject. So I divide everything by pi r squared. I will split it up. So 108 pi over pi r squared minus 1/3. I will just put it in front times pi r squared square root 8r squared all over pi r squared. Oh, what do you notice? Pi cancel away, r squared cancel away. Right? What else? Pi also cancel away. You're left with 108 over r squared minus 1/3 multiplied by square root 8r squared. Okay? Clear? Very good. Okay, now maybe I'll just make it as 108 times r power -2 minus 1/3 times square root of 8 times square root r squared. But of course, square root r squared, they cancel each other off. So we are left with just r. Okay, so 1/3 square root 8, 108 r power -2 minus in between. Okay, Very good. So now we move on. So that is part 1 done. Part 1 is a very common question. Make into a single variable only. So part 2, show that the total surface area ACM square of the solid is given by the formula A equals to 4 pi bracket 54 of r plus r squared. How? How to find total surface area? So it's a toy. It's a toy. So don't think of it as a building. So it's a toy. Let's say that you want to paint the surface of the toy. So there's how do you get the total surface area? What you're supposed to do is to draw the 3-letter word. And sorry?
Sure.
Net. You know what's a net, right? If it's a cube, the net will be hopscotch. Like this. Total surface area will just be the area of each of these squares. Right? So convert from 3D into 2D. That's the idea. Is it clear? Okay, now for this part, because this is a cone, the 2D drawing is a bit difficult to draw. Right? So let's just deal with the cuboid first. For the cuboid, this one is easy to draw. You can split it up. If you can imagine the curved part here, it's actually you take an A4 piece of paper, you curl it up together, you get the curved surface area. So and when you unravel it, it actually becomes a rectangle like this. The top surface and the bottom surface makes up two circles, but we don't need the top one. Why we don't need the top one? Why?
Because it's not a surface area.
It's not exposed. This part is glued together already, so it's not exposed. Okay, so only one circle. What's the radius of this circle? R. Okay, good. So what's the? Okay, let me just get. Okay, no, I need to keep it. What's the length of this rectangle here?
2R.
2R.
I mean 4R.
4R. No.
I mean H.
Imagine, where did this come from? Nope. H is this side here.
Where did this side come from?
Opposite
Is it
sides
not
of rectangle.
4R?
No. It wraps itself around the circumference of the circle, right? So it's the same as the circumference. So it's what's the formula for circumference?
Pi R. I mean not pi R, pi D.
Pi D, yes.
Pi.
The E is 2 radiuses, right?
Yeah.
So it's just 2 pi R. Must remember the formula at 2 pi R. Okay, 2 pi R. Yes, good. So we essentially got the surface area, half of it already. We got the area of rectangle, length times breadth. We got area of circle, pi R square. Not enough, we still need the curved surface area of a cone. I'll just give you the formula. For the cone, the curved surface area, you need to use pi R L, where L is the what kind of height? Slant height. Okay. Good. So in this case, the curved surface area of a cone is actually a sector. It's actually a sector. Is it important? Not important. Never mind. You split it up into a sector. Then the area of this sector is pi RL. R is just the radius of this base. So we can just use that R. But what's the L? L is slant height. What's the slant height? Is it H?
3.
Is it L? Is it R? Oh, it's 3R. Okay, again. So after that, you times 3R, and as a result, you get 3 pi R squared. Okay, good. So that is the curved surface area. But this one, what is the area? Area of a rectangle. Okay. It will be 2 pi R times H plus how many circles?
Plus 1.
One circle only. So what's the formula for area of circle?
2 pi R square.
Pi R square. Very good. Okay, so now you notice a problem. Here's R, suddenly got one H or one out.
Sub H.
With
in terms of R.
Got the formula here, right? So
Yep.
we're going to use that. Copy and paste. So that means that we end up with 2 pi R on the left, 1 0 blah blah blah, whatever we found from part 1 on the right, multiplied, plus pi R square. Okay, that is the surface area of this net from the cylinder. This is the surface area from the curved part of the cone. Total surface area will be just the sum. This guy plus 3 pi R square. Can you imagine doing this under exam condition?
No.
This is not the only question you're dealing with. So a lot of students find this very difficult. Yeah, so you should practice under time condition. Try, legit. Experience the stress. If not, you go exam, go engineering, then you really do the questions there. It's only going to get tougher, and it's also under time condition. Yeah. Time yourself. Like try and do one question in 15 minutes. If you exceed 15, GG. Practice, then you will go faster. So yeah. and other tricks to help you to go faster, you must memorize the formula, even though the formula is provided. If you want to go fast. Okay, never mind. Let's just see how we can simplify into this simple expression from such a monster expression. Okay, let's see. So I'm just going to see that there's a 4 pi here. Then here got pi r square. Let's see. Okay. This first part we can in fact rewrite it as 4 pi r square. If I just quickly expand the answer that they're asking us to show, we distribute the 4 pi into the first guy, we get 4 times 54, which is 4 times 54, which is a 216 pi over r plus 4 pi r square. Is this correct? Yes, So we see 4 pi r
Yes.
square, 4 pi r square. Okay, we are 50% there. The other 50% is to show that this is the same as 216 pi over r. And then we pretend to factorize and we get that final answer. Okay, so let's just multiply in 2 pi r times 108 r power negative 2. 2 times 108 is 216. What a coincidence. Then pi is just pi. R times r power negative 2 is r power negative 1, right? That's an invisible positive 1. 1 minus 2 is negative 1. Yes? Good? No? Okay. Then 2 pi r, you multiply by this guy, negative 1/3. We get negative, let's see. A bit off. I think I did something wrongly. Maybe there shouldn't be this expression here. Because I can see that it's the same already. This first term, this last term is the same as this. So this middle term, something is wrong. I should not have a negative 1/3 square root 8r. Let me double check my work. Where did you come from? How to find a mistake? Here's how you do it. You trace your working. So this shouldn't be here, which in turn came from here, which in turn came from here, which came from here, which came from here, which came from here, which came from here. Volume of the cone. Let me see. Did I do something wrongly? Well, I cannot find the mistake. Square root 8 is square root 4 times 2, which is square root 4 square root 2, so it's 2 root 2. Does that help? Not really. Interesting. Is there something wrong with the question, or is there something wrong with my working? Okay, I am not sure what is going on here, but I feel that my working is correct. Do you think it's wrong? Mic test. Are you still there?
Yeah.
Yes. I'm not sure. I think my working is correct. Maybe the question was wrong. Got this from a prelim paper. Oh. I feel like there should be this expression here as well. Okay. Let's say that I'm wrong. Let's say that I'm wrong. I'll get back to you on this one. If we follow along with the question, right? Total surface area A is given by this guy. For part 3, part A and B, find the value of R for which A has a stationary value. It's the same standard procedure. Just use that star. Okay, actually just test. Okay, then this one is star. Table. Do I need to go through?
No.
Don't need. Okay, I think you understand. And that will be all for today. Your homework. Please finish up the rest of the questions.
Okay.
Okay, you need to practice. All right, that's all. Bye-bye.
Okay. Thank you. Bye-bye.
Thank you. Bye-bye.